9.2 Special Right Triangles. Essential question: what is the relationship among the side lengths of a 45, 45, 90 degree triangles and 30, 60, 90 triangles? Before we start, let's go ahead and review some square root information. All right, the square root of 36 is 6. The square root of 49 is 7. The square root of 64 is 8. And the square root of 100 is 10. So when you take a square root of a perfect square, it's just that number. Now, I'm writing this again, but instead of writing 36, I'm writing 6 squared. The answer should be the same. And it's going to be 7, it's going to be 8, and it's going to be 10. Now, let's take a look at what this answer is. Now, remember, this is a square root of 12 squared. So the square root and the square are undoing each other, and that's why we get the number 12, just like we got on the others. So when we take the square root of x squared, the square and the square root undo each other like adding or subtracting, multiplying or dividing, and we get x. This is the kind of thing you're going to see in a few minutes. All right, we're going to take a look at a 45, 45, 90 triangle theorem. It says that the two legs are going to be the same, and that the hypotenuse will be root 2 longer. Now, if you put root 2 in your calculator, it's about 1.414. So in other words, whatever you multiply by this number, or root 2, you're going to make it longer, which makes sense because the hypotenuse should be longer. But why is it root 2? So let's take a look at why it's root 2 and not something else. I just drew several squares. Here's a square that's a 3 by 3. And I'm going to use the Pythagorean theorem to figure out the hypotenuse. I get 3 squared plus 3 squared. Instead of making them 9, I'm going to say I have 2 of these. So I have 3 squared times 2. And then I'm going to take the square root of both sides. Now when I take the square root of both sides, that square root of 3 squared becomes a 3. We just talked about that. But the 2 has to stay in the square root. 5, 5. Square, I'm going to get 5 squared plus 5 squared. I'll have 2 of these, so I have 5 squared times 2. I'm going to take the square root of both sides, and when I do that I get c equals, and the square root of 5 squared is 5. We just talked about that a few minutes ago, but the 2 has to stay in. So it looks like we're seeing a pattern. In this right triangle I have a 3, and the hypotenuse is 3 root 2. In this right triangle, I have a 5, and then the hypotenuse is 5 root 2. Over here, we can see the same thing is happening. If two sides of a right triangle are exactly the same, then the hypotenuse will be root 2 longer. 10, 10, and you can see that the hypotenuse will be 10 root 2. So in general, we can say that when you have two sides that are exactly the same, x and x, then the hypotenuse will be a root 2 longer, x root 2. Now, the ratio of all of these is 1 to 1 to root 2. So that, when you reduce the ratio, that's what it becomes. Both of these are going to be the same, and this will be root 2 longer. This is the strategy we're going to use to help us find lengths. So this is a 45, 45, 90 triangle. And what we're going to do is, instead of we can't use the Pythagorean theorem because we don't know two sides. But we can use this idea of this ratio. We know 45, 45, 45, 45, 90 has this ratio of x, x, and x root 2. But we're going to even make it simpler. We're going to say 1, 1, root 2. Now, to help you out, we're going to set up a proportion. And in the bottom, we're going to write the ratio, 1, 1, root 2. And what I'm going to do is I'm going to take this number and I'm going to put it above a 45, above one of the 45 ratio representations. So I'm going to put an 8 here. And I know that if this is 45 also, then this will be 8 as well. So I'll put an 8. And then the hypotenuse I'm going to put above the root 2. So I know that the sides go 1, 1, root 2, and I know that this particular triangle that is similar to it will be 8, 8, and then I'm going to try to figure out. Maybe some of you already can tell the answer, but if you can't tell the answer, then we can cross multiply, and therefore x is equal to 8 root 2. You may have already figured it out that it was 8, 8, and then 8 root 2. All right, let's take a look at this problem. And in this problem, again, this is a 45, 45, 90 triangle. How do I know? Well, these two sides are the same, so that forces these two angles to be the same. So I know that the ratio is going to be 1, 1, root 2. And to set up the problem, I can set up a proportion, and I'm going to put the ratio underneath, and then I'm going to put x above the ones because those are the opposite the 45-degree angle. So this is going to be x, x, and then I'm going to put the hypotenuse above the root 2 ratio here. And you might be able to see the answer. If you don't see the answer, then we can just take one proportion like this. I am going to reduce it, and then I get x is equal to 5. Some of you may have already figured out it was 5 without going through all of this work. Okay, your turn to try to figure out what x and y are. Go ahead and stop the screencast. And here are the answers. X is equal to 2 for number 1, and for number 2, the x is 2. And again, I'm showing how you set up the proportion. The denominators are the ratio for 45, 45, 90, and then you put the numbers in that you know and then solve. The next triangle we're going to work with is a 30, 60, 90 triangle. And it says that the short leg and the hypotenuse have a 1 to 2 ratio. In other words, this is twice as long as this. And it says that the medium leg or the longer leg will be root 3 times the short leg. Now let's see why this is happening. Let's go ahead and take a look. This is an equilateral triangle. Equilateral means all the angles will be 60. Notice I put a 60 here. That means this is going to be a 30. So I'm going to get this 30, 60, 90 triangle. I am now going to use the Pythagorean theorem. Since this is a 30-degree angle and it's also an altitude, I know it's cutting this into half. So I know that this is going to be 6 squared equals, and I'm going to call this b because I'm looking for it. So this is 3 squared plus b squared. And so this is going to be 36 equals 9 plus b squared. B squared is equal to 27, and when I take the square root of 27, that's going to be 9 times 3, which is 3 root 3. So I had the short side, which is 3, the long leg is 3 root 3, and then the hypotenuse is 6. So notice this relationship between short side and hypotenuse, and notice this relationship between short side and long leg. Okay, let's do it again. This is going to be a 30-degree angle. This altitude is cutting this in half, so that's 5, and I'm going to call this b. So this is going to be 10 squared is equal to 5 squared plus b squared. B squared will be equal to 75. Therefore, b will be root 75, which is 25 times 3, and so b is 5 root 3. So let's write them all down. Short leg is 5, long leg is 5 root 3, and hypotenuse is 10. Look at the relationship between short side and hypotenuse, short side and long leg. So in general, if this is an equilateral triangle, this is 60, this is 30, then this thing will be cut in half, so that's going to be an x, and this is going to be our b. So I'm going to write c squared, I have it right here, is equal to a squared, which is x squared, plus b squared. This is 4x squared equals x squared plus b squared. B squared is equal to 3x squared. Take the square root of both sides, and I'll get b is equal to square root of x squared times 3. I'm putting the 3 in the back. Remember, this is going to simplify to x root 3, which means you're multiplying by root 3. So the ratio is x, x root 3, and then 2x. These are the sides. Now, what we do is we write this as 1 root 3, 2. So we leave off the x's because if you multiply by anything, it's going to be a similar triangle and it's going to have that same relationship. So let's take a look at this problem. Okay, step 1 is to set up the triangle. So remember, we're working with a 30, 60, 90 triangle, and we know the relationship is if we call this 1, then this is going to be twice as big, and this is going to be root 3 times the short leg. So I'm going to write 1, that's going to be opposite the 30, root 3 opposite the 60, and 2 opposite the 90. So I'm going to go here, and I see opposite 60 is 9, so I'm going to put a 9 here, and opposite the 30 is x, so I'm going to put x here above the 1, and then I'm going to put y over here. So this is the ratio for 30, 60, 90, and this is, again, the sides of the new triangle. So they all have to be proportional. The sides are in proportion. All right, I'm going to multiply these two, so this is going to be x root 3 equals 9. I'm going to divide both sides by root 3, and I'm going to get x is equal to 9 root 3. Now your algebra teacher should have said that we don't like to leave things in a root in the denominator, so I'm going to multiply the numerator and denominator by the number 1, and then I'm going to get 9 root 3, and in the denominator I'm going to get a 3, and this simplifies to 3 root 3. So the short leg is 3 root 3. The long leg is 9, and now I need to find y, and so to find y I'm going to cross multiply. 18 is equal to root 3y. Now I can go through this and solve, but I really already know that the hypotenuse is twice as big as the short leg, so I'm just going to take a shortcut and multiply it by 2, and I'll get the same answer with my algebra, or I'll get the same answer understanding the relationship. Okay, here's your opportunity. Go ahead and I suggest that you start with your ratio, 30, 60, 90 ratio, which is 1, root 3, 2. Go ahead and put these numbers in. It looks like we're not looking for the hypotenuse, so all you'll have to do is work with this part right here. This is a 30, 60, 90. Remember, this whole thing is 4, so this is an equilateral triangle. Here's your 60, here's your 30. So keep that in mind as you do this problem. And here are the answers. Now, over here, I have two ways to find the answer. I could have multiplied these two, or I could have gone along and multiplied these two as well. Okay, equilateral triangle. They're wanting us to find the area of the sign. So I drew it twice. This is going to be my base, and that's going to be 36. And so really what I need is the height right here. I need the height to put it in to find my area. Now remember, this is 60, and this is 30. And this is 36 because it's equilateral triangle, and I know this is 18. So I know that this ratio that I keep pushing is 1 root 3, 2. And I know the hypotenuse is 36, so I put 36 over here, and I know the short leg is 18, and this is what I'm looking for right here. I'm looking for the height, so I'm going to put h right here because that's what I'm looking for. So I can either use this proportion or I can use this one, and I am definitely going to use this one. This is going to go a lot faster. H will be equal to 18 root 3. So that's what I'm going to write here, 18 root 3. And I'm going to do some canceling, and then I'm going to get 18 squared, which is 324 root 3, and then I'm going to actually times it by root 3 to get an approximation, and that approximation is 561.2 square inches, and that's how much area a yield sign will give. Okay, here's some more application problems. Suppose we want to find the height of the ramp right here. We want to find the height, so we'll call that x, when the tipping angle is 30 degrees. And we do know that a ramp is 80 feet. So they want us to find this. So I'm going to use my 30, 60, 90 relationship, 1, root 3, 2, and then I'm going to put, this is the hypotenuse, so I'm going to put an 80, and this x is opposite the 30 degrees, so I'm going to put x. And it looks like I'm not going to need this middle portion right here. I'm going to cross multiply. 2x is equal to 80, so x is equal to 40. So the height of the ramp is 40. Now what if I make the tipping angle 45 degrees? And this is still 80. Now before we start the problem, do you think the height will be larger or will it be smaller? So we're going to call this x. Let's go ahead and set it up. Remember, this is a 45-45, which the ratio is 1, 1, root 2. And I'm going to put 80 in the hypotenuse spot, and I'm going to put x here and here. I really don't need to, when I find one, I'll find the other. So this is going to be, the answer is x is equal to 80 root 2, but I don't like to leave a root 2 in my denominator. But I think what I'll do is I'll just go to my calculator right away and put that in, just so that I can see what that number approximates. And I'm getting approximately 56.6. So those of you who decided that when the tipping angle is greater, the height is greater, you were right. Okay, now your turn. Go ahead and see if you can do this. Stop the screencast and do the problem. And here are our answers. Okay, this is the end of the screencast.